Ladies and gentlemen, my name is Bálint Molnár. I'd like to talk about the little issues in insurance industry, and we would like to discuss the challenges, opportunities regarding the insurance industry, how they may use customer behavior analytics, risk assessment in this new data analytics environment. The rise of fintech and the changing consumer behavior and advanced technologies are disrupting equally all the financial services industry. Among them, one of the subsectors, the insurance industry. The insurance industry is preparing for the process of digital transformation, and how the industry should conduct business is an issue, and the other one that the exploitation of big data capabilities should be investigated. That approach lies at the center of the digital transformation. The insurance industry has been using data to calculate risks for years. However, new technologies are now available to collect and analyze large volumes of data for patterns and to yield better risk prediction and calculation. The value of understanding how to store and analyze it has grown exponentially. The insurance industry is at its relatively early stage of discovering the potential of big data analytics, and several technology companies are investigating how to make the value of such technology for financial industry business in finance. Equally important is to note that the majority of insurance companies are left with legacy systems, legacy enterprise and insurance industry systems, processes inherited from the 1980s. The changes in society, economy, and business brought more pressure on the insurance industry. Due to the big volume of data generated by insurance industry, it is especially important to enable the best use of them. In this talk, we discuss opportunities and challenges in implementing data lakes for insurance companies, and we propose a potential strategy for leveraging data as a strategic asset for enterprise decision making, especially in the domain of customer behavior analytics and risk assessment. We present potential data lake reference architecture, the issues related to data warehouse, and the mapping between the different components of data lake to Zachman architecture. Also, we identify potential future challenges that the companies will face due to the use of big data. And we conclude what, in our view, will be the new business logic of insurance companies in digital era. Pushing our concept how to leverage data lake and data warehouse architecture within insurance industry. Pricing and underwriting in the insurance industry means that estimating the price of an insurance policy is based on the complex risk assessment process. Big data can give the ability to more accurately price each customer comparing individual behavior compared to a large pool of data, a process that allows the insurance companies to correlate behavior to risk. This is most visible in car insurance. Car insurance, the setting the claims, means different solutions that are devised already, namely automated claims setting, especially based on the domain of car insurance, where the company has a large amount of data and already from past data can fully automate claim report and their response to them. Insurance companies can execute and automate decisions related to big data, such as whether the insurance company should pay the claim or not. The next area is the monitoring of houses. The insurance companies can use and distribute IoT devices to monitor a range of activities at home by comparing the real-time data collected from the IoT devices about the house risk. The insurance companies can intervene before a claim occurs by recommending the policyholder to adjust the high-risk behavior, such as forgetting to lock the door or set the alarms. Big data can be used to understand patient risk and prevent health issues before they arise. One way may be through drawing insights from big data to better make predictions and recommendations to customers for different insurance policies and their coverage. By collecting medical records and multiple sources or information regarding attitudes towards health like wearable of phone data. Generally, organizations are full of data that are stored in existing databases. These data typically produced by various information systems. And nowadays, data streams are coming from mobile applications, as for example social media, web information systems, and other devices that are linked to the Internet, namely Internet of Things, IoT. The collected data can be considered as heterogeneous data because of the structure and the content. They are structured, semi-structured, and unstructured typically. Some of them are accompanied by metadata. There is an essential difference regarding data capture in traditional business information systems and information systems for financial industry, especially the insurance industry. In the financial industry, the initial data gathering is typically manual, and even the structured data contains plenty of textual information. The input data are created typically by human agents who can make errors in data either intentionally or unintentionally. Examples of error-prone data entry can be the following: name, address, identifiers, for example social security number, tax number, and so on. Thereby, the metadata entry leads to imprecise data that makes difficult any data mining exercises. For example, association relationships that may have been found proved to be erroneous. The problem with that practice is that it conceals the subtle differences among the electronic customers' records that would be precious for data analytics and knowledge discovery, information that is produced by automated systems, along with autofill and edit check options, as for example speech-to-text, OCR, optical character recognition, that computerize customers' data may introduce systematic and random inaccuracies that differ from clerks to clerks, software to software tool. These errors are difficult to quantify and anticipate. Generally, it is assumed that the data coming from source systems are in good quality. However, the market and administrative forces have not enforced a satisfyingly high level on standards of data quality. The typical life history of data can be seen in figure. On the left part of the diagram, the various major source systems of financial data can be seen. The data are represented as customers' electronic personal records, geocodes for geographical information, and other loosely coupled data related to management and business administration. To overcome the data quality limitations of data warehouse, the idea of the data lake is conceptualized. The touted idea of data lake is that it deposits data in their original form. That is, the figure contains the data after an ingestion phase, so that the data lake collects structured data from relational database management systems, semi-structured data, binary data, and unstructured data, along with metadata that are represented typically in semi-structured format. The ingestion phase may mean loading, batch processing, data stream processing of source data, while the necessary quality checks are carried out utilizing the MapReduce capability. The essential property of the raw data zone is that it is considered as a single source of truth, as it keeps the data in their original form. However, the masquerading and tokenizing of the data may happen in that zone. Data scientists, business data analysts can return to that zone when they look for associations and relationships that may have lost during data conversion, transformation, encoding, and encrypting. For researchers, managers, and other subject area experts who would like to pursue exploratory data analytics, the architecture provides opportunities to set up models, discover associations and relationships among attributes, without involving members of the IT department and other extra costs. The researcher can bring data into specific zones of data lakes from any other source within a controlled environment. It is even allowed to export interesting results back to the raw data zone for reuse. Within a hybrid data lake that contains a robust data warehouse as well, the life cycle of data commences with transformation, cleansing, and integration. The objective to build up a data lake is to separate the daily operation, transactional data from the non-production data collection. Historically, the data warehouse technology has been employed for that purpose. During the staging phase, the data are cleansed and filtered for the target data structure within the data warehouse, the fact table, and the dimensions. The phase of data staging includes data migration, data integration, translation of codes used for data representation, the transformation between database management systems, and so on. The data warehouse served as a basis for data analysis traditionally, and the ETL extract transform load procedure is applied for feeding data into the data warehouse. During that step, the general data cleansing and transformation happens. While the data transformation is carried out, relationships among entities may be dropped or harmed. Similar way, the data integration for multiple source systems can lead to errors that are transmitted into data warehouse. To overcome the data quality limitations of data warehouse, the idea of the data lake is conceptualized. The idea of the data lake is that it deposits data in original form. The figure contains the data after an ingestion phase, so that the data lake collects structured data for RDBMS, Relational Database Management Systems, semi-structured data, and unstructured data, along with metadata that are represented typically in semi-structured form. The ingestion phase may mean loading, batch processing, data stream processing of source data, while the necessary quality checks are carried out utilizing the MapReduce capability. The conceptual perspective describes the core to which the system is dedicated. In the case of business intelligence workflow in insurance industry, the objective is to assist the management to formulate the research questions in terms of business processes. In the conceptual level, the disparate methods that are devoted to specific research questions and associated with various approaches of data analytics appear. In the logical layer, the specification of the business intelligence workflows is exhibited using business process description languages, algorithms of data analytics, and services for data access. The logical level should contain the explicit specification of access rights taken into account of the different regulations, especially GDPR and sector-specific prescriptions. The physical layer contains the technology-specific arrangements, solutions, besides the actual programs containing algorithms of data science, data preparation activities. The physical level should contain the number of physical level data processes, executors, that carry out the particular workflow, the number of concurrent tasks, the allocable memory, and so on. The implementation and operational layer, the detail level, depicts the data analytics workflows on an infrastructure that contains nodes of data processing that are realized as commodity hardware and the decomposed models into details respectively. The insurance industry that tries to follow the mainstream technology and not to put emphasis on data analytics and the application of big data related technologies. Traditionally, the financial industry generally and the insurance industry especially are interested in the consumer groups that can be defined by age, gender, online activities, social and economic status, geographical distribution. In the financial industry, the enterprises customize their services and products to encounter the requirements of every customer fragment. Naturally, consumers are not treated equally. Those who have bigger affordances, affluent consumers, are traditionally being treated better. The identification and special treatment of these affluent consumer groups are important, and the use of data lakes and data warehouses can significantly improve the process of detection of different target groups. Another of the benefits of exploitation of the big data technologies in the financial industry is to offer fraud detection approaches. The insurance industry gravitates towards online services on a large scale, so there is a high chance to be the victim of a fraud. Data science assists the companies in the financial industry to understand their consumers' behavior, even the patterns of online actions. The key to fraud detection is in making use of more contextual data. In the financial industry, banking, payments, and insurance, the concept of personal touch in services acquires importance, and it becomes the most significant tool for marketing, the rivalry among the competing companies, and forces the enterprises to adopt such personalized type of services. In the insurance industry, the personal recommendation may include how to save money by a combination of insurance policies, which combine insurance policy with investment, has benefits for the consumer, and so on. Once more, such data can be easily generated from data lake of the company. The application of data analytics methods cannot make the potential risk avoidable. However, it offers the identification of potential risk in a timely fashion. The techniques of data science can assist enterprises in the financial industry to adapt their company strategies and business processes to minimize the risk. It has recently become commercially viable to create risk profiles for individual customers, defined by factors such as age, gender, health, work activity, place of residence, driving behavior, etc., and the willingness to pay and make the categories corresponding individual offers. One of the frontiers in applying the data lakes will be exactly in this, how to do it fast given that the data is transformed during analytics. Developing new or more sophisticated risk models can enable insurers to offer more competitive rates or to offer insurance for previously uninsurable risk, due to information gaps that today are filled in by the increased availability of data. Data lakes in this regard make the work of a data analyst in a company much easier, and the use of a new analytical methods would be faster with the use of data lakes. In this figure, we present the basic structure of the data-driven insurance. The data collected will be analyzed in real time in the data lake. Visualization will be presented to insurers, and the insurer can decide on optimization in offering and product or pricing. This information can be presented further in knowledge graphs and can be used for the generation of reports with new insights. The execution of advanced data analysis tasks between business and the IT department. In this paper, we have presented our first attempt to talk about the ongoing problems in the insurance industry. We have raised issues that what would be potential advantages and challenges for use of data lakes in the insurance industry. We have reflected for the problems that how these new business environments will influence customer behavior analytics and risk assessment. And lastly, we have discussed industry adoption and challenges that may arise. Besides, we have presented the basic structure of the digital insurance ecosystem, with data lakes and data warehouses being at the center of it. Big data and new ways of integrating data in the digital transformation, such as integrated approach, will foresee the development of new open business intelligence models to better detect similar cases among data and stress similarity, and then explore potential reuse of the same effort for different businesses. The future of insurance will be data-driven, and there will be the need to manage risk, even if data makes it easier to estimate it. The pace of change, however, is big, and modern data structures, like data lakes and data warehouses, will give rise to new business models for their functioning that will change the way they work as today. Thank you for your attention, and if you have any questions, please put it.